Hello and welcome to this new video. In the previous video, I showed you the adaptations to make for EOS crossplay on Steam regarding player data storage, presence and logout, as well as the features supported on Steam concerning external UIs. I mentioned that you can follow the Steam section as the default platform to adapt your crossplay project with Steam on these topics. In this video, we will adapt our project to support crossplay, meaning matchmaking between Steam players and also between Steam players and EOS players. As I already mentioned, creating a lobby session will crash the editor due to a bug in the EOS plugin. I want to show you in this video how to fix it and make matchmaking possible in your game. As you can see, the crash message indicates that there is an assertion failure in a C++ file of the EOS plugin. What happens is that the EOS plugin code checks the network ID type of a player, and if the type is not EOS, the assertion fails, causing the editor to crash. In the case of EOS+, the player's network ID type is EOS+, not EOS, so the assertion is not valid. The plugin should check that the player's network ID type is either EOS or EOS+, not just EOS. What we will do is change the assertion code to implement this logic. It's not complicated in terms of coding since it's just a single line to change. The problem is more with building the plugin after this change. It's important to note that if you modify the source code of an Unreal Engine plugin, the change won't take effect unless you rebuild the plugin after the modification. To build the plugin code, you need Microsoft Visual Studio as the IDE, where we modify the plugin and rebuild the solution. I already have Visual Studio installed on my machine. If you don't have it, you will need to install it first. As you can see on line 12 of this file, the assertion checks that the network ID type is EOS. What we need to do is add an OR operator to support the EOS plus type. This line will be as follows. So the condition will be, if the type is EOS or EOS+. To modify and build the plugin, we first need to copy it into the plugins repo of our project. The plugin is located in Engine Plugins Online. Once copied, we need to generate the C++ project files. To do this, we must add an empty C++ class to our project. Click on Tools and then on Add C++ class. Add an empty class. Wait for the editor to generate the C++ project files. Click on OK, and the project will open in Visual Studio. Alternatively, you can open it by double-clicking on the .sln file. Search for and open the file of the plugin to modify. Modify the assertion. Save the file, then build the solution for Development Editor Win64. Right-click on the solution and click on Build. Be careful, the build will fail if you have Unreal Engine open, so you need to close it before building the solution. Wait for the build to finish. You should have a successful build with 0 errors. Close Visual Studio. Now the plugin is built, and the change is taken into account. We need to move it back to its original folder, which is Engine Plugins Online. Delete the existing version, then paste the modified plugin. Now go to your project to delete the version under Plugins. All set, the session creation should work now. Be careful, if you verify your engine or reinstall it, you will need to repeat this process. You can delete the C++ project and the source folder if you want. Launch the game to verify the creation of a lobby session. And as you can see, everything is working properly now. The Steam player was able to create a session on the EOS backend. You can go to your dev portal to verify it. Now that we have verified the creation of lobby sessions with EOS Plus, I'm going to talk to you about the limitations of EOS Plus regarding session management. I've noticed that EOS Plus does not return a callback when we register or unregister a player in a session. The process works fine, but no callback is returned to inform us that the process has completed successfully. The same applies to the destroy session process. The session is destroyed, but no callback is returned. Just to remind you, registering players in a session is useful so that the player can use local checks such as is player in session. Get name sessions. Here, neither of these two callbacks will be triggered. For an EOS player to play with an EOS Plus player, we need to specify in the EOS distribution that the game accepts the net ID mapping between EOS and EOS Plus. This is done by adding this configuration in the default engine .ini of the EOS project. To test, launch an EOS client and an EOS Plus client. Create a lobby session on the EOS player side and join it from the Steam player side. And there you go, the game scaling works well. Two players from different storefronts can connect and play together. Try to invite the EOS player while they are already a member of the Steam player session. The already in session message will appear, which indicates that the player is properly registered in the session. If the EOS player leaves the session, they are properly unregistered locally, and we see the message because on the EOS side, the callback is correctly triggered. However, on the Steam player side, we see an error indicating that the player cannot leave the session. This is because the leave process calls the destroy session task, which always returns a false callback. Go to the master player controller to fix this. You just need to continue the leave process without considering the callback from the destroy session task. Now we want to fix another limitation. In fact, the session notifications delegate doesn't trigger on Steam. Just to remind you, we use this delegate to unregister a remote player from the session when the local player receives a notification indicating that a player has left or been removed from a session. Since this delegate doesn't trigger, we need to implement the unregister process in the master game mode, as we did previously for the register process. It will be simple. We just need to duplicate and adapt the function. Don't confuse the unregister function, which is only executed for the player leaving the session post-logout, with the unregister process that needs to be executed for every other member in the session. What I want to do, therefore, is modify this function so that it executes for every member of the session. The process will be the same as the register process. We loop through the player cards and call the unregister for each member's controller. One of the limitations to consider is that EOS Plus always returns false when sending a session invitation to a player, even though the invitation is sent correctly. So, I want to remove the message displayed on the screen because it doesn't reflect the correct result. Note in the game instance that this delegate does not trigger, and that we have replaced it with an alternative solution. You can therefore remove this implementation. We also need to ignore the callback from the destroy task in the level World 1 when the player leaves the match. This is done in the macro library that is used to execute the destroy process. Everything is well adapted on the lobby session side. We now want to test the matchmaking, including dedicated server matches. Launch a Steam client and an Epic client. Create a lobby session on the Steam player side and join it from the Epic client. If you speak, you should hear your own voice. Start a player-hosted match. There you go. Everything is working well on the lobby session management in a match in a game scaled across 2 platforms. The player data write error is normal because we haven't enabled this service for Steam. You can disconnect the call to this process in the character blueprint. Return to the lobby. The match should end. The lobby session has been successfully destroyed. Launch a dedicated server from the EOS distribution. Verify that the 2 players can search for and join the dedicated session. Start a dedicated match. Both players should be able to connect to the match. They should also be on the same team and able to chat via voice chat. There you go, everything is working as expected. Repeat the test by launching a dedicated server now from the Steam distribution. Verify that the players can connect to this server. There you go, everything is working well. You also need to verify that 2 Steam players can play together. So, you must copy your project into VMware and launch the second Steam player. Create a lobby session and verify that both players can connect. Start a player-hosted match. The process is slow on VMware. It depends on the specs allocated to this VM. Now try to connect the players to a dedicated server. And there you go, everything is working as expected. We've successfully started our game on 2 different platforms, and players can play together regardless of their storefront. That's all for this video, see you in the next one.